Hello, algebra students. So today we are going to be talking about our library of functions that you explored already and you came up with the different graphs. So now we're going to go back through those graphs in a more formalized way. So hopefully we are familiar with a linear graph. We have the form y equals mx plus b, or f of x equals mx plus b, and it's a straight line. So you'll write in your description, straight line. So for each of these, you're going to write down the description of the graph, and I've added a few extra things to each one. Next, we have our absolute value function, and to remember that it's a V shape. As always, anytime you need a little bit more time to write things down, if the video is going too fast, make sure to pause and then restart whenever you're ready. We have our square function, or our quadratic, and that's going to be a U-shaped function, or a parabola. Our cube function is sort of an elongated S shape that's sideways. And our square root function is just half of a parabola that's sideways. It's not the entire parabola sideways, just half. Now our exponential function is going to be flat on the left side, and then it curves upward and gets steeper on the right. And my nickname for it is ballerina because it sort of looks like ballerina arms. This particular exponential function has a base of 2, but we can vary the base. We can have different bases there. Okay, so now we're going to get a little bit more in depth. We're going to review each one of these, but you'll notice each of these graphs matches one of our library graphs on the other page, but they're all shifted around and something has happened to both of them, to all of them. So our first graph up here, number 1, we have half of a sideways parabola, so that's our square root function. Okay, and so the parent graph equation is just like on the front of your notes. We're going to have the equation f of x is the square root of x. Okay, and we're just trying to recognize what the parent graphs are. Later, we'll look at what exactly is happening, like this one has been shifted to the right 5 spaces and down 1, and we'll get into those equations. So go ahead and try to identify what each of these parent graph names are, and then look on the previous page for the equation. Pause the video if you need a little bit more time. Okay, so now you can double check your responses. We've got an exponential curve, and again, the base is 2. We've got a square or quadratic function, and an absolute value function. You should have the equations and the names of all of these. Okay, we're going to do the same thing at the bottom of the page. So try to identify the type of each graph and then the equation of the parent graph. Okay, you can go ahead and double check your work, make any corrections that you need. So now that we have our library, what we can do is we can graph transformations based on the original. If we know what the parent graph is going to look like, then we can do things like shift or flip our graphs in many different ways and draw more complicated equations without a ton of work. So on this first one, we have our absolute value function, and it's asking us to shift it to the right 3 spaces. So I like to start with the main point, in this case the vertex, where the absolute value curve meets in the middle. And I'm going to start by shifting just that point 3 spaces to the right. Then I like to take the key points that surround it and use those but in relationship to that point. So this next point here is 2 to the right and 2 up from the vertex. So I'm going to go over here and I'm going to go 2 to the right and 2 up and draw a point. I'm also going to go from this point 2 to the left and 2 up. So I'm going to do the same thing here. 2 to the left from that vertex and 2 up. And then I can draw any more that will fit, right? So then I can go from this point 2 left and 2 up. So that's here. I'm going to go 2 left and 2 up. And hopefully we recognize that absolute value curves are linear on either side of the vertex, and then we can draw in as many points as necessary. Use a straight edge on these. They should be sharp V-shaped curves. So when you're ready, you can double check your graph, and it should look just like this. Make sure you fill the entire grid. So the entire graph has been shifted to the right 3. Now we're going to take what we've already shifted to the right 3 spaces, and we're going to shift it 4 spaces down. So again, I'm starting with that vertex point, and I'm going to shift that one from here 4 spaces down. Then I'm going to take each of the other points in relationship to that vertex, and I'm going to move those. So I'm going right 2, up 2, and that's where this point comes in. I'm going to go left 2, up 2, and get that point. And I'll keep mapping these out until I can draw enough of my curve so I have an accurate picture. Both sides should be linear again. You can go ahead and double check. So every point on this previously shifted graph has now been shifted down 4 spaces. So the shape of the graph doesn't change. The only thing that changes is where it begins. Next, we're given our parent graph, f of x equals x squared. And so you can see underneath in each one of these, you have a little blank. In yours, it says parent function, and you can put in, and it says square function, you can add to it the parent equation. Because what we're really going to be looking at is what's happening in the equation and what does that do to the graph. So one thing that is good to remember is when you have a square function, each of these points are little perfect squares, okay? So if we're thinking about each one as their perfect squares, we can think of them as their ordered pairs. So 0, 0, 1 squared is 1, 2 squared is 4, negative 1 squared is still 1, and negative 2 squared is still 4. So in our first equation, we've got minus 2 inside the parentheses. So that's changing this in the x direction. So in the x direction is left or right. Remember, we always do the opposite inside. We can think of this in terms of vertex form. And so since it says minus 2, that means we're going to be going to the right 2 because it's in the x direction. That's either left or right. Right is the positive direction. So we're going to shift everything to the right 2 spaces. So again, I'm going to start with that vertex point. 0, 0 is shifting 2 spaces to the right. Then every other point surrounding that, they were both right and left 1, but up 1, I'm going to move those in relationship to that vertex point. And then right 2 up 4, and left 2 up 4. Then I can draw in my nice smooth S-shaped parabola. Hopefully yours looks a little nicer than mine because I'm trying to use a mouse to draw mine. It's a little bit harder on the computer. All right, so next we're going to take a look at x squared minus 1. So we're going back to our parent graph and we're saying minus 1. And so when we look at that, remember we can always think of our equation by moving. So remember when we look at something like this, we can always think of our equation by moving the constant to the other side if that's helpful. So it might be helpful to rewrite your equation in this form. And I just used y instead of f of x. So now we can see our shift is in the y direction because our shift is over here next to y. And again, we're going to do the opposite. So since this says plus 1, I'm going either up or down. I'm going to do the opposite of that. So I'm going to go down 1 space. So I'm going to take this initial vertex point and I'm going to move it down 1. Then every other point from there, I'm just going to copy over. So I'm keeping the same shape, so over 1, up 1, over 2, up 4. So the shape itself hasn't changed, it's just shifted. So go ahead and complete your smooth parabola. So last, we've got subtraction inside our parentheses, like here, and outside, like here. Again, if it helps you to rewrite, go for it. I like to do that. So now I can see I'm shifting both 2 spaces to the right as well as 1 space up. So now I can see that I'm shifting 2 spaces to the right as well as 1 space down. So I'm doing the combination. So again, I'm going to plot in each of my points. This time I'm going to start with that vertex that used to be at 0, 0, going 2 to the right, 1 down. So that's my starting point. Now every other point is going to follow the same shape, so I'm still going right and left 1 and up 1 from there, because 1 squared is 1. I'm going to go to the right 2 and up 4, because 2 squared is 4. Then I can draw my nice smooth curve in just like the others. Okay, so we can use our transformations to graph any of our shapes, not just parabolas, and we'll see that in the next section.